Welcome back to the instructional series on hierarchy of energy theory, where we unify all physics under one big, beautiful physical model. I am your theory influencer, Scott Gordon. In this segment, we complete the internal energy structure of an ideal photon and show that it is a perfect shockwave through the space-time energy medium. We show how Maxwell's derivation for the speed of light is consistent with hierarchy of energy theory's detailed model of a photon, and reveal that the electric permittivity and the magnetic permeability are also relative constants. In Lesson 7, we showed the important features of a photon's internal structure. At first look, this structure can be a bit overwhelming, so we'll get into a little better understanding and then finally complete the photon's internal structure. Oh, and anyone who is joining us for the first time, please go back and start at Lesson 1. No one, not even if you're a physicist, is familiar with hierarchy of energy theory and its foundation. When a new foundation for the entire field of physics is being laid out, you cannot just start in the middle of it. You must learn hierarchy of energy theory from its beginning, because it builds the entire field of physics and cosmology step by step using only two ingredients. Also, if you're a physicist or cosmologist, take your time when learning hierarchy of energy theory, and feel free to contact me through my YouTube channel's email. Okay, let's get back to the photon. The photon's property of polarization is a consequence of its internal energy structure. The energy field was shown to exist only along the y directions of the photon's xy energy planes. We also showed why the magnetic field exists only along the photon's z directions. Now the question is, can Maxwell's derivation for the speed of light be applied to this model? Of course it can. And it should come as no surprise that hierarchy of energy theory will always be consistent with all our verified theories. This includes general relativity, quantum mechanics, quantum field theory, the Standard Model, QED, and every other well-verified theory we have. Consistency with our current knowledge of physics is the minimum requirement for a theory of everything to have any credibility. Maxwell's derivation for the speed of light plays an important role in showing why a photon represents a perfect shockwave in the space-time energy medium. But first, we will use the established physics of a wave that reached its maximum velocity in its medium. Fortunately, we don't have to get mathematically complicated. We can use simple math to show what happens when a wave moves through its medium at its maximum velocity. We will compare a photon moving through space-time to a jet moving at the speed of sound in the medium of air. As a jet moves at the speed of sound in the medium of air, what is the angle of its wavefront? Well, let's find out. As the jet moves forward, it compresses and displaces air forward. The sound wave created in front of the jet moves at Mach 1. The jet also displaces air in all directions that are perpendicular to its direction of motion. Once the jet reaches Mach 1, the sound wave and the jet are both moving at the same speed. The speed of the air displacement in all the perpendicular directions is also Mach 1. When the jet moves forward a distance at Mach 1, the sound wave generated in all the perpendicular directions of the jet's motion also moves at Mach 1, and therefore covers the same distance during the same time. The angle of the wavefront is 45 degrees. Now, in comparison, let's look at a photon moving at the speed of light. The photon is moving at the maximum speed through its medium, and the jet is moving at the maximum speed through its medium. But there are big differences between the jet moving at the speed of sound and the photon moving at the speed of light. While the jet displaces the medium of air in all directions perpendicular to its motion, a photon can only move and displace spacetime along the direction of its motion within its field of energy. The motion of spacetime's energy along the x direction creates compression or stretching of quantum distances along the x direction, which is then realized only along the y direction of the xy energy plane. The displacement of spacetime along the directional diameter of the photon's primary energy plane drags adjacent spacetime energy, but only the adjacent spacetime on the y direction of the photon's energy plane. It does not drag spacetime energy that lies adjacent to it in the z direction. And at what speed do you think the motion of spacetime along the x direction extends into the y direction? Of course, it's the speed in which energy moves through energy, the speed of light. This progression of space-time motion into the xy energy plane along the y direction results in compression and stretching of space-time along the x direction, creating electric field values on the y direction of the photon's xy energy plane. The speed in which these electric field values extend into the xy plane's y direction is represented by the electric permittivity. Now here's the interesting part. The shearing of spacetime that occurs because of the spacetime's displacement on the primary xy energy plane will also spread along the z directions to reach the secondary energy planes. Note that there is no displacement of the z direction. What is happening along the z direction should be considered a twisting that creates a shear in the adjacent secondary energy planes. The shearing results in displacement of spacetime energy on the secondary xy energy planes. The displacement created on the secondary xy energy planes results in compression or stretching of spacetime along the x directions, which in turn generates the electric field values in the y direction of the secondary energy planes. And do you want to take a guess at what speed the shearing of spacetime proceeds along the z direction? Oh yeah, it's the speed of light, the speed in which energy moves through energy. The speed in which the shearing of spacetime proceeds along the z direction is represented by the magnetic permeability. This model represents the very strong correlation between a magnetic field and an electric field at each point in the photon's energy field. Both fields are directly related to the compression or stretching of spacetime energy on the xy energy planes as the photon moves at the speed of light in the spacetime energy medium. The induced displacement and shearing of spacetime's energy advancing into the y and z directions of a photon's internal structure is how a photon's energy is distributed throughout its entire region of energy. The photon is a perfect shockwave in spacetime because it cannot lose energy into spacetime as it travels through spacetime at the speed of light. But what's the angle of the photon's wavefront as it moves through spacetime? Well, its angle is also 45 degrees. But how do we know this for sure? Well, I'll tell you how. Because Maxwell's derivation for the speed of light tells us so. Using Maxwell's model and equation to derive the speed of light, we come up with this expression. Both the electric permittivity and the magnetic permeability represent the speed of energy moving through energy, which is the speed of light. When the directional diameter of the primary plane moves at the speed of light, it contains the compression and stretching of spacetime. It causes a displacement and shearing of spacetime's energy that proceeds along the y direction at the speed of light, and this speed is represented by the electric permittivity. Similarly, the magnetic field shearing moves along the z direction at the speed of light, and this speed represents the magnetic permeability. In other words, while there is no displacement of spacetime energy along the y and z directions, as it would be seen in the example of a jet, there are energy fields that represent the energy of the photon moving at the speed of light along the independent energy directions. Let's take a closer look. We see that when the leading tip of the directional diameter moves at a distance at the speed of light along the x direction, the electric and magnetic fields will also move the same distance at the speed of light along their respective directions. This creates the 45-degree angle of the photon's perfect shock wave as it moves through spacetime. So putting this all together, the primordial ideal photon is cone-shaped, and it is a perfect shock wave moving through spacetime. The photon's length in the direction of motion is its wavelength, and its electric and magnetic fields extend infinitely outward along their respective energy directions at the speed of light. The strength of these fields decreases the farther away we go from the directional diameter. And there you have it, a physical model of the ideal primordial photon that includes its internal energy structure. The internal energy structure of a photon plays an important role when we get to quantum electrodynamics and photon interactions with particles of the second energy tier. And yes, Professor Feynman, we will finally be able to understand quantum mechanics. But we still have many lessons to learn before we get there. Maxwell's derivation for the speed of light tells us that both electric permittivity and magnetic permeability of free space must both represent the speed of light. One cannot be larger than the other because that would mean that either the electric or magnetic energy field would be moving faster than the speed of light in the space-time energy medium. And that can't happen. It also means that just like the speed of light, both electric permittivity and magnetic permeability of free space are relative constants, as they both represent the speed of light. I'd like to point out that space-time can have differing energy density values along its independent energy directions, and it doesn't matter what the photon's orientation is as it moves through this space-time. The electric permittivity and the magnetic permeability are relative constants, just like the speed of light and Planck's constant are relative constants. For those of you familiar with Maxwell's derivation for the speed of light, you can see that hierarchy of energy theory's model shows that at every point within the photon's region of energy, it satisfies the conditions set forth for his derivation for the speed of light. I would also like to point out something for those of you who are interested in or developing string theory. String theory has some merit as it shares some components between hierarchy of energy theory. The directional diameter of a photon is essentially the string in string theory. And a similar correlation will be seen when we reveal the internal energy structure for particles of the second energy tier. There is so much more to learn when we move up the hierarchy of energy's next energy tier, E equals mc squared. This is the energy tier of particles that contain mass. Hierarchy of energy theory's physical model tells us how these particles come to exist, what their internal energy structures are, how they have mass, how they become associated with what is known as the Higgs field, and how they come to have their properties of spin and electric charge. I'm sure you are all very impatient to get to this next level of enlightenment. But before we move on to the second energy tier, we are going to have some fun with the knowledge we have already gained from hierarchy of energy theory. Our new understanding of spacetime and photons are the tools we can now use to answer some of the biggest, most perplexing questions in physics and cosmology. As we tackle each question, you may get the feeling that we are onto something. And as we advance hierarchy of energy theory to the second energy tier, this feeling may become very difficult to resist, even for the most ardent skeptics. In our next lesson, we take on these questions. What determines the property of straight? Does our universe have a border? And if so, what's beyond it? What is the true void? What is inflation and what causes it? What is dark energy? And what's the story behind the cosmological constant? What caused the Big Bang? Why is the universe composed of matter over antimatter? If you are curious about this novel approach to finding the theory of everything, then click the like button below and subscribe to this channel so that you can be notified when future lessons are released.